We talked a little bit about how describing parametric equations in terms of a single parameter t instead of saying y is a function of x is really useful. However, one thing that's even more useful is if you not only have parametric equations, but if you actually can describe one as a function of the other. What that allows you to do is kind of get a best of both worlds, because in sort of like real world data, you might be looking for correlations, you might be looking for how one thing might determine the other. So if there's a way to decouple how the parametric equation is unfolding and actually write one as a function of another, you can analyze it directly. Now, one thing you lose when you do this is you lose the orientation. So the strong recommendation for anything like this is to plot it beforehand. So remember, when we would plot it, you'd plot the t value, the x value, and then the y value, and then you'd have t go from, pick useful values, maybe start negative, go to positive, get the xy values, plot it, and you can see whether or not it's moving this way, whether or not it's moving that way. That tells you about the flow. But sometimes you don't need to know the orientation. Sometimes you just need to know the relationship. And that's what we're going to do here. Anyway, the key to doing this is there's two ways to do this. There's the brute force way, and there's sort of the clever way. And we're going to try to do a little bit of both. The first one is here. So what you want to do in these is you want to get t by itself. So a lot of times we want to get y as a function of x. So we're going to get t by itself here. I'm going to say, all right, well, if x is 4t minus 3, then I know that x plus 3 is equal to 4t. And then I can divide both sides by 4. I get 1/4 x plus 3/4 equals t. So by doing that, then what I can do is I can say, well, y is a function of t, so I can replace the t with this expression here. So I know that y is 3t plus 1, so y is 3 1/4 x plus 3/4 plus 1, plus 1. So y is 3/4 x plus 9/4 plus 1, or y is 3/4 x plus 13/4. And that's really all you have to do there. And that's one way to do it. Now the other way to do that, we're going to be a little more clever in the next one. Not super clever, but a little more clever. So I have x is equal to t minus 4. Now, very clearly I could say t is equal to x plus 4, right? That's pretty simple and straightforward. And then you can say, all right, well, everywhere I see a t here, I'm going to replace it with an x. But you don't have to be, you could do that. That would be fine. Everywhere I see a t, I replace with x plus 4. That'd be fine. But why don't you do this? Why don't you say y equals x plus 4? But why replace that here? You know that t minus 4 is x directly, so it's just x. This would be a fine answer, but I kind of prefer this. This helps me understand that it looks like 4 over x, but it's shifted up by 1. I like that a little better. So again, don't work harder than you have to. If it's already in a convenient form, just plug it in. So let's continue on rolling. This one I've got x is t cubed, y is 1/2 t squared. Now this one we're still going to have to kind of do it the old-fashioned way. What we want to do is we want to get t by itself. We say, all right, if I take the cube root of both sides, I get that the cube root of x is equal to t. Another way to say this is x to the 1/3 power is equal to t. And then once I do that, I can plug it in here. I can say, well, y is 1/2 x to the 1/3 squared, so y is 1/2 x to the 2/3. And that's another way to do it. So that one's not too bad at all either. The final one looks nasty. It's really not. It depends on how you want to do it. So we're going to do it what I consider to be the easy way, and then we're going to do it sort of the long way, just so you can see that they're equivalent. I got e to the t and I got e to the 3t. So the key is to rewrite this in a very convenient way. You can say, all right, well, e to the 3t is e to the t cubed. Okay, so e to the t cubed. Well, that tells me that y is x cubed plus 9. Well, that's easy, right? No problem at all. Now, let's say you didn't know how to do this. Let's say you had a lot of trouble and you just said, I got to do this old-fashioned way. Well, that's fine too. If you start here, you take the natural log of both sides. So t is the natural log of x. So then you say, well, y is e to the 3 natural log of x plus 9. So y, if by the log rules, remember we can raise it to a power. We can bring this up to the top, plus 9. And we also know that e and the natural log are inverse functions. So e to the natural log of something is just that something, which of course gets us the same answer. So it's not like you had to work extra hard, but by using some convenient algebraic rules, we were able to very, very quickly get our answer. So, don't work harder than you have to. Be a little bit clever. Do some practice until you can develop that cleverness.